Hello, this is Guillermo Campitelli, and in this series of videos you are going to see a case study in which the interest is to investigate the effect of numerical variables on another numerical variable. So that's what typically is known as regression analysis. So we are going to use linear models and regression here. Okay, so in this case study, we use again the data set that we used in previous videos. In this case, instead of investigating the role of some variables in academic achievement, the variable that we are going to use as dependent variable is psychological well-being. And the model is that the variables income and job of choice are predictors of psychological well-being or cause changes in psychological well-being. Of course, there are unknown variables that are also part of the model. Okay, so first, descriptive statistics of this study. We are going to use JASP. So we've got JASP here, we've got the data, and we go to descriptives, and we are going to get descriptive statistics, and we look at the variables that we are interested in, which are income, job of choice, and psychological well-being. So we put all these into variables, and here we get the descriptive statistics. We go to plots, and we can get distribution plots. So we've got distribution for each of the three variables that we are interested in. And we can do box plots in this as well. We get a box plot of each of the variables instead of the distribution. And if we like the violin, we put violin. Violin and box plot together doesn't go well, so let's get rid of the box plot, and we get the violin plot over there. And we can, if we put jitter element, it will show all the values. So each dot will be one value. Okay, so that's in terms of graphs, but we've got another graph that we can now use, which is the correlation plot. And it's a nice one because it shows, and I have to extend here. So it shows the correlation plots between the three variables, and in the diagonal the distribution that I showed you before. So this is a nice plot when you've got 3-4 variables. When we've got a lot of variables, then it becomes a bit too big for so many variables, but it's nice here. You can see the relationship between the three variables and the distribution of each variable as well. Okay, so this is the descriptive statistics, and if you want something else in statistics to look at, okay, you can choose the median, the mode, the sum, percentiles, variance, etc., etc., etc. So whatever you want to appear in this table, you press here. You've got a median, mode, skewness, kurtosis, standard error of the mean, although it's not technically a descriptive statistics, and so forth, so on and so forth. Okay. Okay, let's now move to parameter estimation, and as always we are going to see the traditional frequentist approach, the Bayesian approach, and the resampling approach. And in the traditional frequentist, we are going to estimate the mean of each variable. That is our estimation of the mean of the population for each variable. The correlation between variables, again, we are estimating what's the correlation in the population, and the regression coefficients, so how the two independent variables, of the strengths of the relationship of the independent variables with the dependent variable. Okay, so let's use JASP. So for the estimation of the means, we just use the descriptive statistics that we've seen. We add the standard error of the mean. So go to descriptive statistics. We drag the or we click the variables of interest, income, job of choice, and psychological well-being. Go to variables, and in statistics we want the standard error of the mean. And when we got the standard error of the mean, now we can manually get the confidence interval. So for each variable, we've got the standard error of the mean. We multiply these values by 1.96, and in order to get the lower bound, we subtract 1.96 times this value from the mean, and that's the lower bound, and 1.96 times this value, we add that to the mean, and that's the upper bound. So if we do that, we're going to get these values. So for income, the point estimate of the mean of the population is 80,590.5, and the confidence interval is from 79,440 to 81,740. And for job of choice, the mean point estimate of the mean is 55.3, and the range or interval estimate of the mean is from 52 to 58.5. And for psychological well-being, the interval estimate is from 52.1 to 54.5. Okay, so that's the mean of each variable. Now, in order to estimate the correlation, we go to regression and correlation matrix. And again, we put the variables that we are interested in: income, job of choice, psychological well-being, put there, and we get here the correlation matrix. So here you've got the Pearson correlation between the variables and the p-value to determine whether it is significant or not, but we are in parameter estimation, we are not interested in the significance. So what we are interested in is in the confidence interval. So we tick here confidence interval, and it gives us the upper and the lower bounds of the confidence interval of the correlation coefficient. So this is our estimation of the correlation between job of choice and income. The point estimate is 0.099, and the lower bound is negative 0.014, and the upper bound is 0.21. And for psychological well-being and income, the point estimate is 0.203, lower bound 0.092, and upper bound 0.309. And for the correlation between psychological well-being and job of choice, the point estimate is 0.4755, the lower bound 0.3829, the upper bound 0.5587. So with this, we've got our estimation of the correlation coefficient of the population. next step is to obtain, to estimate the regression coefficients. Okay, so now we are going to do the regression coefficients, and we are going to use also JASP, but now we are going to use regression instead of correlation, and we are going to make something a bit different. So what we're going to do is we're going to use center variables, except for the dependent variable that we are going to use psychological well-being as before. For the covariates or the independent variables, we are going to use centered. So center basically is, instead of using the original values of the independent variables, what we are going to use is center values, and center values are calculated very easily. So for each variable, all the values, we subtract the mean from all the values. So values that are lower than the mean will have negative values, and values that are higher than the mean will be positive. And if there is a value which is exactly the mean, that would be 0. So why do we do that? We do that because we are going to calculate the interaction between variables, and I'm going to explain why it's important to do that. So let's first put center income and center job of choice. We put them as covariates, and here we've got the table that shows us the correlation, the regression coefficients. Okay, so basically here center income, we've got the unstandardized coefficient with the standard error and the standardized coefficient. And for center job of choice, unstandardized with standard error and standardized. So when we want to calculate to estimate the regression coefficient of the population, then we need to use the standard error. As usual, we multiply this value by 1.96 in order to calculate the lower bound and upper bound of the parameter. And the same with this value, we calculate the lower bound and upper bound of this parameter value. So that would be our estimation of the regression coefficients. But what I said that we want to also incorporate the interaction between these two variables, and we do that by going to model. We highlight both variables, and then we press the arrow. So basically that incorporates the interaction. And as you can see, the way the symbol that denotes the interaction is the star, which is multiplication. In a lot of software, the star is used as multiplication. And in fact, what happens is that on the background, a new variable is created, which is by multiplying the values of center income and center job of choice. And that variable is added into the model, and the regression coefficient of that variable, of how much it affects the dependent variable, is what we get here. So why then we center the values? We center the values because when we do this multiplication of values, if we don't use center values, it could be the case that one of the variables is more correlated with the with the dependent variable than the other, and when we generate this new variable by multiplying values, the values may be similar to more similar to one of those variables than the others, and this will affect our estimation of the effect of this new variable. So in order to avoid that, what we do is to center values, and then both variables will have a mean of 0, and then we multiply those values, and that will solve that problem of one variable being more similar to the dependent variable, one of the independent variables being more similar to the dependent variable, and when we generate this new interaction variable, and will be more weighted towards one of the variables. So it would be very similar to one of the variables. But by using center values, this doesn't happen. Okay, so that's the reason why we use centered values, and basically it's very easy. We subtract the mean from all the values, and that gives us the center values. Okay, so the only thing that probably we need to talk about is what's the difference between unstandardized and standardized values. And basically the difference is that unstandardized values tells us what's the increase in units of the dependent variable as a function of increase in units of the independent variable. So if center income increases 1 point, then the psychological well-being will increase 0.0002. Now income is a variable that has much higher values than psychological well-being, so let's consider an increase of income of 100, because an increase of 1 is very, very small. So an increase in income of 100 will produce a increase on psychological well-being of 0.02. An increase of 1,000 in income will produce an increase in psychological well-being of 0.2, and an increase of $10,000 of income will produce an increase in 2 points of psychological well-being. So that's what it's saying. With job of choice, an increase of 1 unit of job of choice will produce an increase of 0.1685 psychological well-being units, and an increase of 10 points in job of choice will produce an increase of 1.68 points in psychological well-being. Okay, so now the interaction is an additional increase, and the interaction is how one of the independent variables affects the relationship between the other independent variable and the dependent variable. So basically, let's say that we are interested in the relationship between income and psychological well-being. Well, this relationship is 0.0002, but if this interaction is positive, which it is here, but it's quite small, what it tells us is that at higher values of job of choice, the relationship between income and psychological well-being will be a bit stronger. If the interaction is negative, it means that the higher the values of job of choice, the relationship between income and psychological well-being will be a bit smaller. So that's what an interaction tells us. the additional increase in the relationship between one variable and the dependent variable as a function of increase in the other, the independent variable. Okay, so now these are the unstandardized with standard error, and the unstandardized are expressed in units of the dependent variable. So an increase in units of the dependent variable as a function of an increase in 1 unit of the independent variable. Now, the standardized uses z-scores. So, and it uses z-scores for both the independent variables and the dependent variables as well. And so, remember z-scores, you have to subtract the mean as we did with the center values, but then you also divide by the standard deviation. So, and that gives you the z-scores of the variables. Now, the standardized regression coefficients indicate an increase of one standard, what's the increase on standard deviations of the dependent variable as a function of an increase of one standard deviation in the independent variable. So that means that if we increase one standard deviation of income, the increase in psychological well-being will be 0.158 standard deviations. And an increase of one standard deviation of job of choice would produce an increase of 0.4599 standard deviations of the dependent variable psychological well-being. Okay, so this is the difference between standardized and unstandardized. And this one is 0 because the intercept, because with set values, all the means are 0, so the intercept will be at 0. That's by definition. Okay, now let's move to the Bayesian parameter estimation, and we can use JASP as well. So instead of going to linear regression, we use Bayesian linear regression, and we use we are not going to estimate the interaction, so we can use the raw scores without centering. Okay, so now what we have here is the base factor, and we are going to use that for later on for model comparison. But we can get the posterior distribution by putting here marginal posterior distributions. So here is the posterior distribution, and that's the distributions we use to estimate the parameter. So this parameter is the intercept. So basically this gives us the 95% confidence interval of this distribution, so between 52.2 and 54.3 is our estimate of the intercept, and here it's income 5.7 e minus 5 in scientific notation to 2.6 e minus 4 in scientific notation. That's the estimate of the regression coefficient for income, and then job of choice, the posterior distribution, its confidence interval is from 0.129 to 0.201. So that's our estimation of the regression coefficients using Bayesian parameter estimation. So the only thing I need to say about that is that what are the priors? So that's the posterior distribution. So the priors, we use the default prior that JASP uses, which is a beta distribution, a Cauchy distribution. Remember that the Cauchy distribution is similar to the normal distribution with scale parameter 0.354, and so basically that parameter determines how spread the distribution is around 0. So for all the betas, beta 0, beta 1, beta 2, which was the intercept and the effects of income on psychological well-being and the effect of job of choice on psychological well-being, the prior is a sort of normal distribution with mean of 0. So basically it's saying that values close to 0, both negative and positive, are more likely than values far from 0. And when JASP does the calculation, uses standardized values. So it calculates the standardized because that's why it centers in 0 and not in other values. So basically the idea is that the same prior would work to any parameter, but obviously if we are using unstandardized parameters, it shouldn't be the same. The prior shouldn't be the same for each parameter, but because we use standardized, we can use the same prior. Now, on the background is doing that, but when we've got the results reported in JASP, we get the unstandardized. So it transforms the standardized into unstandardized, and these are the values we get here. Okay, so that's the Bayesian parameter estimation of regression coefficients. These are the posteriors. Now let's move to resampling. Okay, for resampling, I did it with R, so I'm not going to show you the software. Just to explain what I've done. Basically, what I did was to generate new samples from the original sample. So with the original sample, we've got the 3 variables, and basically what I did is to obtain one row of values randomly, and then put that row of 3 values back to the original sample, and again randomly choose another row of 3 values and put it back, and so on and so on. So I generate a new sample of the same number of values which has rows of values that were in the original, but we did it by obtaining it randomly. So basically we've got a new sample. What we do there is to calculate a regression of the so we can obtain the beta 0, which is the intercept, the beta 1, the effect of income on psychological well-being, and beta 2, the effect of job of choice in psychological well-being. And we do that with one sample. We record that value and then we do the process again. So we obtain we obtain a new sample by sampling from the values of the original sample, and we obtain the beta 0, beta 1, beta 2 again, and we repeat that process thousands of times. So we have thousands of beta zeros, thousands of beta ones, thousands of beta twos, and we can generate a histogram with those values. And these are the histograms, and these are the summaries of the histograms. For beta 0, the point estimate is 3.76, and the interval estimate is from 22.7 to 38.9, and for beta 1 the point estimate is 0.000164, and this is the interval estimate, and for beta 2 0.168, with this being the interval estimate.